stops at A. The second function starts from A. You know what that means? It means that if I try to apply between 0 to and I try to calculate, the derivative of this wave function and equate it to 0 or whatever. When I do it from 0 to A and it doesn't give me a result, between A to B, it doesn't give me a result. Now think why it won't give you a result. Because in between there is a stoppage, there is a discontinuity in the function. That is the reason why it won't give you a result. If it were not for this discontinuity at A, it would give you the result. But now think, between 0 to A, between these 2 points, the function is continuous. Between A to B, the function is continuous, right? Where is the discontinuity? It is at A. The function needs to have some maximum probability somewhere. What this means is that if between A 0 to A it is continuous and it doesn't give a result there, and between A to B it is continuous, it doesn't give a result there, where the point of discontinuity lies, there is the maximum probability. What is that? That is at point A. So x equals A is where you have the maximum probability for finding the particle. So all you have to do is look that here you have two different wave functions for this particle. Between 0 to A you have this, between A to B you have this. That is a discontinuity in the overall function, and thus you have your answer. The point of discontinuity, x equals A. From that the slope changes, the graph changes. So you have to only observe this very little thing and you have solved this particular problem of quantum mechanics intuitively. No mathematics to carry out. You don't have to plot that graph. You can solve this question of quantum mechanics just using your intuition and basic logic. Hence it proves that quantum mechanics can be understood intuitively, or rather not a very proper term to use, understood, as many physicists themselves say, including Richard Feynman, that I think it's safe to say nobody understands quantum mechanics. Why it happens, what happens, you don't know. But there are some things even in quantum mechanics that you can understand with a little bit of intuition. There are some such things as this question. You can understand it. Or this was more like on a mathematical level, but still there are some things that can be understood on an intuitive level, even in quantum mechanics. Otherwise, what it would be just a plain sheet of formulas, but it is not. It does exist. So there is some intuition behind it, and you need to understand the formulas and learn them and try to solve them, and then you can try to make sense of the formulas. You will never understand. To exactly understand quantum mechanics, you'll never understand that. You'll never understand why these formulas exist or what is the true machinery behind it. You'll never understand that. But you can at least hope to understand little that what the formulas are telling you. What the Schrodinger equation tells you, you can hope to understand that it tells me this. You can know what quantum mechanics will tell you. You cannot understand it because you don't understand the machinery behind it. That's
एक क्वांटम मैकेनिक्स दूसरा कौन है?
relativity.
Relativity.
Relativity can be understood. Relativity is understood, specifically even
अच्छा ये
general.
बताइए क्वांटम मैकेनिक्स है क्या? Just define करो.
It is basically the study of light and matter on a very small scale, on the subatomic scale. Light and matter. That's what quantum mechanics is.
इसमें किसका रिसर्च है जो फॉलो किया जाता है?
Now, see, quantum mechanics has many different formulations, many different interpretations. There is no single correct form of quantum mechanics. You can use this form of wave function, you can use Schrodinger equation and stuff and calculate wave function. You can do quantum mechanics this way. You can use Feynman's path integral formulation. There are many different formulations in quantum mechanics. That aside, there are many different interpretations of quantum mechanics. Now, even if you consider the Schrodinger's, let's say that you have wave function, you calculate it using Schrodinger equation, whatever. See, now if we ask a question that where was the particle before we did the measurement, or when we don't observe this thing, where is the particle and this and that, when we ask that, so there are many different answers that we can give to this particular question. Now the most accurate right now being that the particle wasn't really anywhere, or at least our observation gave it that particular question, position. But even for this, aside from this, there are many interpretations. There is the many worlds interpretation. So quantum mechanics isn't like a single theory that you follow, or isn't given by a single person. Many different scientists have tried to understand it, have tried to understand the particles and how you understand it, how you try to understand it, or not even understand again isn't very proper word, but there are many different formulations to it and interpretations, and we cannot right now prove, we cannot prove that which interpretation is the correct one. You cannot do it.
अच्छा, इसको समझने के लिए किसकी बुक पढ़ते हो?
Griffiths,
बीटेक से
Griffiths, Feynman.
फाइनल भी कंटेंट पे लिखे हैं।
Read Griffiths, Feynman.
ये समझ में आते हैं? वो दिन से रखा है।